Formatted input output. We have seen how to input output or how to read and write data using unformatted read and write statement. In case of unformatted read and write statements, we specify either what to input or what to output. In these category of statements, that's called as formatted statements, we also specify how the data should be entered in case of read statement and how the data should be displayed in case of write statement or print statement. The syntax is slightly different. You can see that the syntax is read followed by a star asterisk. This indicates default source, comma, format statement number n. So this n is statement number of format statement. So format statement specifies format of input, that is how the data is to be entered. After this we get a list of input variables. This example shows how to use formatted read statement. This is one example. This is statement number of format statement. So the format statement must have this statement number. So this number indicates that format statement numbered 100 will be used for this read statement. Here there are three variables. First variable is x, which is a real variable by default. So the data will be accepted using this specification f10.2. That means the data must be entered in first 10 columns, and there will be decimal point after 2 digits. There will be 2 digits after a decimal point. Important thing is, while entering data, we can enter a decimal point according to our choice, and in that case this part will be ignored, that is 0.2 part will be ignored, and it is preferable to enter decimal point while entering real data, because otherwise it puts a lot of restrictions on the user. Next value is value of k, that will be accepted from next 5 columns. So first 10 columns is reserved for x, next 5 columns for k, and the next 8 columns for z. User must enter data according to this scheme. First 10 columns for x, next 5 columns for k, and the next 8 columns for z. So value of x will be in first 10 columns, this is what it says, value of k in next 5 columns, and value of z in next 8 columns. It is important to note that real values must have a decimal point. So when you enter data, you must enter data with a decimal point. Otherwise the user will have to follow additional rules while entering data. Important thing to remember is that the formatted input statement puts restriction on the user, and therefore this statement is not preferable, or this is not a preferable way of entering data, because the program should not put restrictions on the user. Let us demonstrate use of unformatted read using some examples. So this example uses formatted read. So this statement number is statement number 10. This is statement number of format statement. Here we try to read data, that is the value of a, b, k and l. Here the first specification is f10.2. That means first value will be accepted from first 10 columns, next value from next 10 columns, then third integer value, that is third value, that is integer value from next 5 columns, and last value from next 3 columns. To give an idea how to enter data, I have written a write statement here. So the first 10 columns I have displayed A, the next 10 columns I have displayed B, next 5 columns I have displayed K, and next 3 columns I have displayed L. Actually there are only 9 A's, because the output is displayed one character to the right, and therefore the actual width occupied will be 10, but there will be only 9 A. There will be one blank space at the beginning of line. So let us see how to enter data using formatted read statements. So first 10 columns 1 to 10 will be reserved for value of A. Next 10 columns are reserved for value of B. Next 5 for value of K, and next 3 for value of L. Let us say value of A is 66.677. I can enter value of B anywhere here. Let's say 457.7. Integer values must be entered right justified. Let us say value is 777 and then 6. Press enter and you see the output. The output will be displayed, has been displayed using same format, and therefore you can see that the output is displayed aligned with this character using 10.2, 10.4, I5. So because this is I5, there will be blank spaces to the left, blank spaces to the left of each value. Occupies only 2 characters, there will be blank space to the left of this number. So this is how we can use formatted read statement. Let's move back to the presentation. Next, we get formatted write statement. This statement is used for displaying values of expressions listed in specified format. Because it is a formatted write statement, it displays according to format. We have actually seen a demonstration of formatted output in the previous example. The syntax is like this: write default destination, comma, format statement number of format statement. N is the statement number of format statement. Then list of expressions. This is similar to unformatted, right? This is the only change. These are some demonstrative examples. Let us go back to the program demonstration. Here, value of A will be displayed using different format specifications: F10.2, F10.4, E10.3. This will be displayed in decimal format. Second value will be displayed in decimal format. Third value will be displayed in exponential or scientific format. Let's execute this program. So this displays value of A in 3 different formats. Important thing to remember is the format statement can appear anywhere in the program. It need not be written after the read or write statement. Next is formatted print statement. Syntax of formatted print statement is like this: print n. This is the statement number of format statement. So we write the result word print followed by statement number of format statement, list of expressions, and these are the examples. So because this is very similar to write statement, we can simply copy these statements in the program and we can run the program. Let's move to next statement or next part. So here we get a list of field specifications or something called as edit descriptors, which are used for formatting the data or formatting input and output. So for integer we use I descriptor or I field specifications. The syntax is in this form: N I W. Here I indicates the field specification, N is number of characters or number of columns, sorry, N is the multiplication factor. So N indicates the number of times same specification will be used, and W is the width or number of characters that will be allocated for this data. So default value of N in all these cases is 1. If it is not specified, it is treated as 1. So here the example is I5. This is same as writing 1I5. So here 5 spaces will be reserved for displaying this or accepting data. Second field specification is for real number, that is decimal format, F, N, F, W, D, repetition factor. number of characters. This is total number of characters. You can see that this is the example. This is total width allocated, or number of characters, and D is number of digits after decimal point. So number of digits after decimal point, whereas W indicates total width, which includes space for the decimal point, number of digits after decimal point, digits before decimal point, and sign if any. So this is how the specifications are used. I field specification, F field specification for real number, real numbers in exponential form, E real in general form, either exponential or decimal depending on size of data, G double precision, we use D field specification, the format is almost same, and for character we use A field specification, repetition factor, then number of characters. So if value of W is 25, that means 25 characters will be displayed. If actual size is more, the string will be truncated. If actual size is smaller, then there will be blank spaces to the left of string. And you can directly display data by enclosing text in quotes like this. For example, if I type something like this in the format specification, this will be displayed. So text can be displayed using one of the two formats, either this A field specification or quote specification. See how to display characters. See, the specification is star comma 10 is 10 format is A5, so that means this string will be displayed. Actually only 5 characters of this string will be displayed, and in second case 8 characters of this string will be displayed. Only 5 characters in first case, 8 in second case. You can change this number. You can change this number to, let's say, 20. We know that there are only 10 characters here, so if I display this using 20 characters, I should get output like this. Okay. So there are blank spaces to the left of string because the actual size is smaller than this width available. There will be blank spaces to the left. So these are the additional edit descriptors. To leave blank spaces, we can use X field specification. The syntax is NX. For example, 20x will leave 20 blank spaces. Then there are tabs. TN. Here N is some number. Tab to column N. So if I write T20, then the output will begin from column number 20. This is tab right specification. Tab right, let's say 5. So that means the output will be displayed 5 characters to the right. In this case, TLN or TL10 will display output 10 characters to the left. This is format specification for new line. So the next item will be displayed on next line. So if there are 2 slashes, then there will be 1 blank line, and this is how it works. So this is the specification, write statement and format specification. First value 100, it will be displayed in first 10 characters, so there will be 7 blank spaces to the left. On next line, because of this specification, this value will be displayed in next 10 columns. Then on next line, because of this specification, and T40 indicates displaying value at column number 40. So this value will be displayed starting from column number 40 using this specification. Let us see some demonstrative example. This is the program which displays values 101, 102, 103, 104. First value will be displayed in column number 1 using I3 specification. Next value will be displayed starting from column number 40 because of this specification T40. So next value, that is 102, will be displayed in column number 40. Then third value, that is 103, will be displayed 10 columns to the right of previous value using I3 specification. And then last value 104 will be displayed 30 columns to the left. So that means it will be in column number 30, because this was in column number 50. Somewhere in column number 50, this will move 30 characters to the left, and then the value will be displayed. Here we have demonstrated a slash field specification. So this will move output to next line, this will move output to next line, and this will move to next line. So that means it will leave one blank space, blank line. So let us execute the program. The first value in column number 1, second value column number 40, third 10 characters to the right. See, you can observe the program and output together. 101 is displayed in as first value starting from column number 1. Then T40, so moves to column number 40 for displaying 102. So over here. Then TR, that means move right 10 columns for displaying 103. So it moves right. Then it moves left 30 columns. It will move left 30 columns to display 104. Next write statement displays 201 in first 3 columns, 201 in first 3 columns, then moves to next line, displays value using I3. So 202 will be displayed on next line. This will move to next line, first slash, so that means on this line, and then on next line, that means on this line, and then it will display value of 203. So this is how this program works. So this is all about formatted input output. Important thing to remember here is formatted output formats output according to user requirements, and therefore it is a preferable way of displaying or printing data, whereas formatted input puts restriction on the user, and therefore it is not a preferable way. So for input we should stick to unformatted input, whereas for output we should use formatted output as far as possible. This is end of lesson.